Hi, this is Gary LaRue from Microwave Journal at the 2018 International Microwave Symposium in Philadelphia. I'm talking with Dean White, who is the Director of Aerospace and Defense Market Strategy for Qorvo.
Yep.
And Dean, you just have announced a couple of X-band front-end modules made with GaN technology. Can you talk a little bit about the functionality of those?
Sure. So we're proud to announce that we have these new what we call front-end modules. And in these front-end modules, they're very compact, very small, help our customers with swap C. Inside of that module, you have a TR switch, you have a power amplifier on the transmit side, and then an LNA on the receive side. The beauty of that receive side is that LNA can withstand higher incident RF power. So that's a real advantage. We get to eliminate the limiter on the input. Now
Right.
You would say, well, okay, you eliminated on the input, but what about the output? What's that going to do to the gas or SiGe core chip on the output? But we've designed the LNA in such a way that you can have 4 watts or 2 watts, depending on the product, coming incident into the LNA, but the LNA will never put out more than about 17 to 18 dBm.
Okay.
So it protects all of the circuitry downstream. Now, you'd say, well, okay, this is GaN versus PHEMT, right? So what's the noise figure going to be like? Well, outside of this module, on the receive chain, it's about 1.7 to 2.4, depending upon the product at X-band. So it's still very comparable to that of what you would get with PHEMT for those kind of power levels. So it's a big advantage. And then of course on the PA side, you have nothing better than GaN, right? I mean, GaN is the smallest, most compact transmitter that you can have. And at the RF output, it puts out about 4.5 watts, which is a very nice little X-band array. So anyway, we're very proud to announce that product, that it offers a great swap C for our customers.
And what kind of applications are you targeting with it?
So a variety of different applications. I mean, in particular, like UAV applications, where you have very small form factor that you have to meet inside of, in order to get it in the nose cone of a UAV or at the bottom of a UAV. So very small, very compact, where you might have four products before, all surface mountable on a board. Now it's in one small 5x5, 5x7 size package.
Sounds nice.
Yeah, I think it's a real advantage, and we've gotten a lot of our customers are very excited about this, as well as other products that we have on our roadmap. We'll do a variety of different products, ranging from all GaN to GaN and gas mixture of products for best optimal performance in the system.
So given that it's X-band and there are aerospace and defense applications, are there any export restrictions?
No, these particular ones are EAR 99, so it makes it very easy to export. We keep the power level below the 5-watt range. And because of some new regulations within the U.S. Government, particularly the Department of Commerce, we're allowed to export as long as it's below 5 watts.
Interesting. So you also recently introduced a really high power device, 1.8 kilowatt at 1 gigahertz, which at the time, I don't know if it's been superseded, but it's the highest power GaN device available in the market. Tell us a little bit about the application for that and some of the other performance parameters.
Right, so I mean, so far it is still the highest. We haven't been knocked off the top of the hill yet. So at 1.8 kilowatts from this single transistor device that's mounted into what we call a flange package. So it provides optimal heat. So everything, you think to yourself, that's a lot of heat in one single package. So we've designed it from the very beginning to be able to handle that kind of heat, particularly for like IFF applications where you've got 32 pulses typically. Now there's little different nuances into how IFF actually works, but it covers very well that 1030 band and the 1090 IFF band. So going back to how it's designed, I mean, the transistor itself is designed for optimal pulling the heat out, keeping the fingers further apart. How we attach it inside of the package has also been optimized. And then the package material itself, to be able to pull that heat directly out of the transistor is a big benefit. Now we'll also use this product as well, not just for IFF, but also for L-band and potential applications into S-band as well.
So as I recall, the frequency response extends pretty much beyond just the 1 gigahertz IFF band.
Right, exactly. And that's what makes it usable beyond just IFF, but also L-band and S-band radar products as well. And so we'll be designing some evaluation boards and working with our customers on exactly how would you match the input and output of the device to get the best possible performance. And I might add, it's 77% drain efficient.
Wow.
So very high drain efficiency, competes very well with LDMOS type devices.
And typically, you talked a little bit about the design of the die and the package. Typically, how would a customer mount this in their system?
So typically this would be soldered down. I mean, that's the best possible, so
Right.
you don't get any kind of air gaps in between the package and the heat sink that you're using. So optimally, yeah, I mean, that would be the best possible solution, and that's really the way the package is designed. So you want to eliminate all air gaps at all, because air is
Right.
not your friend when you're trying to pull heat out of a device.
Exactly, exactly. Well, that's very interesting. You've got a lot of new, exciting products, and the aerospace and defense market seems to be growing as well.
Right, yeah, exactly. And we have a lot more products that are coming out, so stay tuned.
Good. Well, Dean, thanks for spending some time here at the International Microwave Show talking about some of the aerospace and defense activities.
Thank you. Thanks for inviting me.
Gary LaRude from IMS 2018 in Philadelphia.